So today we will be solving the question, count the number of inversions in an array. What is an inversion? Inversion says that let me show you an uh, I'll show you what is an inversion. Yes, let's take this example. So let's take an array example. 8, 4, 2, 1. So when we will return a sorted order, what is this? So this is an inversion. That in a sorted order, their index will be nil. Thus that 4 will come the net. This is another. This is another inversion. This is another inversion. This is an inversion, and this is as well an inversion. This is also an inversion. So inversion is basically, you can say that if before sorting, elements I come before element j, and after sorting element I comes after element j, then ij will form an inversion. Correct? How we will count it? Basically, we will be using here divide and conquer. What is divide and conquer? So I will say this is an array. So let's suppose I know that I say this is half array. I know number of inversions in this array. Okay. And I also know the number of inversions in this array. I know the left value and I know the right value. Okay. So this must be. And now to find the total number of inversions. So now to find total number of inversions. It must be left plus right plus number of inversions formed by mixing this array, right? An element with respect to this element or an element with respect to this element. They must not be like itself. The part wise must not be there, right? So like mix. While mixing, how many new inversions can come? So this immediately reminds me of merge. We will use some enhancement techniques in merge. So let's suppose what do we usually do in merge sort is right. So I knew the inversion in this beforehand. I knew the inversion in this part beforehand. No issues? I reordered them, no issues. I reordered them, no issues. So now I will find the inversions while mixing it. So while adding them, like while making them as a sorted array, so what I will be doing, like I will say, okay, 1 is less than 2, right? This is 1 is less than 2. I say that array of I is less than array of j. It's completely fine because then 1 will be in before 2 in the final array as well. Okay, I'll say, oh, that's not an issue. Just move array I plus plus and j plus plus. Well, now we come over here. Sorry. Yeah. So we say that too. Okay. So now we find that array of I is greater than Right? Now, now this will form an inversion, right? Because in my final array, this 2 will come before this 8, right? Am I right? So this will come. And not only for this 8, this 2 will come before all the elements starting with 8. In the previous array, it was after 14, right? Anyhow, it was after 14, but now it's before, it will come before 8, it will come before 9, and it will come before 14. I will just add all these counts to the inversion, right? And then I'll say, okay, J plus plus. Now it comes 4 and 8 is, so now 4 appears after this in my final array, in my previous array. Now when my final sorted array will come, this 4 will appear before this 8, this 9, this 14. So this all pairs form an inversion. Okay? This is how, while merging this array, we will tackle the merging. So how we will be doing it? We will simply call a merge sort function. Let's suppose sort function is 0. I'll write sort of a pseudo code. So I have a start variable. I will say that middle is start plus n by 2, right? And then I will say, okay, while start is less than n. So I'll say that while start is less than n, right? I'll say that there is a middle. So I'll say that count left inversions. Left inversions basically is, I will just call this particular function is sorting function. I'll say that, okay, start from start, go up to middle, and yeah, give me the answer. Then I will call the right inversion. Sort, start from mid plus 1 and give it me till end, right? So I will say mix inversion. So for that I will have to make a new function. Mix will be from entire start. Now obviously it must be encountered already. So let's make a function mix. So we'll do initial, we'll make a left array copy. It will be start to mid. We will make a right array copy. It will be mid plus 1 to 3. So now while traversing, we'll say that, okay, we'll traverse these arrays completely by using double pointing. We'll say that if, like, we will initialize to start. So I'll say that, okay, if array 1 of I is smaller than array 1, okay, array 1 of I is smaller than array 1 of j, just swap, right? Array 1 of I is array 1. Then it's no problem. Else, okay, as you do, array of j is little bit array 1. Here we will add mid minus j. Number of inversions will be added to that inversion. And while this function is I will put this in description. Okay, bye for now.